Hi, everybody. Welcome to Math with ACE, focusing on statistics today. We're going to be talking about the sampling distribution of sample means. What is the sampling distribution of sample means, and what are we talking about here? Right now, we've mastered calculating the mean of a distribution. We have a given set of data points. We know how to find the average, numerical average, and we also know how to calculate the standard deviation. And remember, there's a difference between the standard deviation of a population versus calculating the standard deviation of a sample. When we calculate the standard deviation of a sample, we divide by n minus 1, and for the population, we divide by n. When we're calculating the mean, we add up every single value and divide by n, number of data points. When you calculate the standard deviation, you have the sum of each x value's deviation from the mean divided by n. This is for a population. What if I had a population, let's say, of 4 values? Maybe I have shoe sizes. I have size 7, size 8, size 8, and size 10. And this is my population. Well, in order to find the average of my population, I'm going to add 7 plus 8 plus 8 plus 10. And then I'm going to divide that by 4. And the reason I divide by 4 is because there are 4 data points. That winds up being 33 over 4, which when I divide, I get 8.25. The average shoe size for this population is 8.25. Now, what if I take a sample of size 2 from these 4 shoe sizes? Let's say I take a sample and I wind up getting 7 and 8. The average shoe size for that sample of size 2, I take 7 plus 8 and divide it by 2. That's going to give me 7.5. So that's one average for the sample. What about if I took another sample? Maybe this time I do 7 and 8 together with the other 8. Well, again, this is like 8 number 2. 7 plus 8 number 2 is also 7.5, and that's the sample average for that second group. What about if I take the 7 and the 10? Seven and 10, if I add together 7 plus 10 and divide by 2, I get 8.5. That's my next sample. How many different ways can I get a sample of size 2 that is unique from this group? Well, I've already done 7, 8, 7, 8, 7, 10. What about 8 and 8? 8 plus 8 divided by 2 is 16 divided by 2 is 8. That's another average. What about 8 and 10? 8 plus 10 is 18, divided by 2 is 9. That's another average. And what about the last one, 8 and 10 here? Again, that's going to give me 9. So from this population of size 4, I can take 6 different unique samples. And when I take those 6 different unique samples, let's say I get my sample means. I have 8, 8.5, 9, 9.5, 10, 7.5, 7. So for my sample, I'm going to do that in blue. My averages were 7.5, 7.5, 8.5, 8, 9, and 9. Okay, those were the averages that I get. Well, what is the average of that average? If I take 7.5 plus 7.5 plus 8.5 plus 8 plus 9 plus 9, and I divide that by 6, I think it's going to be 8.25. Let's see. 7.5 plus 7.5 plus 8.5 plus 8 plus 9 plus 9 is 49.5. And if I divide that by 6, I get 8.25. Where did we see 8.25 before? Oh, 8.25 was the mean of the population. Let's graph that population values. We had the population values of 7, 8, 8, and 10. And both of those had a mean of 8.25, and that is by design. If you take a population and then you calculate a certain number, like you grab a sample size, maybe it's 3, and you calculate the average of every single group of size 3, it will be the same as the average of the population when you average them together. A bunch of averages here. So I have my population values, and I know what the average of the population is. Then I take a sample of size 2, and I did every single combination, found their averages, and then averaged the averages. And the average of the averages wound up being the average of the population. And we call this blue graph right here the sampling distribution of sample means, because it's all the sample means that we took from the samples. And the sampling distribution of the sample means tells us that the population mean is going to be the same mean as the sampling distribution. And in notation, that is the population mean is going to be equal to the mean of the sampling distribution of sample means. That's always true. So the means are equal. So I can use the mean of the sampling distribution as an estimate for the mean of my population. What about the spread? Look at the blue and look at the purple. Notice that the blue is less spread out. And there is a factor that it is spread out by, or that it's condensed by. The standard deviation of the sampling distribution, that blue, is going to be equal to the population standard deviation divided by the square root of n. So in this case, we would be dividing by a square root of size 2 because our sample was size 2. What we can do with this information is we can perform inference. So we can create confidence intervals to estimate an average for a population. We can calculate, perform inference and determine whether we have significant evidence for some sort of claim or not. So we can use this to help us perform inference. The idea is to understand the sampling distribution of sample means is every sample of a certain size from a population, and that the average will be the same, but the standard deviation of the sampling distribution is adjusted, it's made smaller by a factor of the square root of the sample size. Let's get into some examples of how we use this information.